Okay, so we're going to look at a few scenarios, okay? So you've just got a job as a general aviator, okay, flying for a crappy company, crappy aircraft, you don't have GPS, okay? You don't have a lot of the things that make flying really easy, and your passenger turns up and he's stinking drunk, farting, burping, he's a nightmare, and you have to fly him somewhere, okay? So your aircraft, okay, is flying along, and you're at, you've reached your cruising altitude, and you're doing 100 knots, okay? And the weather's atrocious, okay? It's really cold, there's icing, the heating on your pitot tube fails, okay? Now we're going to assume that the weather's so bad, there's sleet flying over this as well, that you get icing on the front of your pitot tube, and you also have your drain hole blocked. And your airspeed indicator, okay, is reading 100 knots, okay? So that pressure now that reads 100 knots, that total ram pressure is stuck in there now, okay? It's not going to change. It can't change. So it's almost like you've got your hand, you've got the pressure in there, and you put your hand over it, you stopped it, okay? So it's reading 100 knots. That icing happens, you're doing 100 knots at that altitude, you won't notice anything. You're flying at 100 knots. You won't know the pitot tube's iced up. As you start to climb, okay, you're going up now, what do you think's going to happen?
Airspeed should increase, but it's not going to.
Okay, if you're maintaining the same speed and you're going up, if the system's working properly, it should read 100 knots, okay? But you're going up, but this pressure's staying the same, but this one's doing what? It's dropping, isn't it? Okay, so it's going to be like this pressure is increasing, even though it's not. Okay, it's not increasing because you're flying at the same speed. Okay, and if you were climbing and that was open and that was open, you'd still be flying. And we're talking about a long, slow climb. Okay, so you put on a little bit of power and you're still maintaining 100 knots. Okay, so you're slowly going up, but with this blockage here, okay, what's going to happen is your pressure, okay, is going to look like it's increasing, even though because it's blocked, it's staying the same. This is staying the same, but this is dropping, and we're looking at the difference between these two. So your airspeed will start to overread. So you might get to your new altitude that you've been assigned, and you're now looking at your meter and going, we're doing 120 knots. That's excellent. But then you're doing your navigation, okay, your dead reckoning on your map, and you're going, we should be over this lake by now, and we're not there yet. What's going on? So there are passengers in the back burping, farting, probably vomiting, because the weather's bad, he's had too much to drink. You're having trouble navigating, okay, you're going, I'm not getting where I need to go at the right time, everything else. But all things being good, you're going, okay, I'm going to start my descent now. Okay, so you're going down now, slowly. You've got a nice straight-in approach to the airport, but weather's bad because you've got icing on your pitot tube. You're going into a general aviation aerodrome with a really short strip, so you need all of it to land. You need to land at the correct speed. Okay, as you descend, okay, this pressure is going to go back up again. This is stuck. This is the same. So your airspeed is going to start to do what? Decrease. So suddenly you're on your approach. He's burping, farting, distracting you in the back seat. Okay, and you look at your airspeed and say it says 75 knots. Okay, you're inside the range. You're going to land, so you're going to start putting some flap out to land. Okay, you're inside the range. You need to be at 80 or less to put some flap out. You're in the white arc on your airspeed indicator. So you go, okay, pop some flap out. Bang, the plane starts shaking. You think you're going to die, and you go fluttering, and you're going, what's going on? Okay, but say we survive putting the flaps out at our true speed of 100 knots, okay, even though it's telling us we're at 75. You're still going, that was weird, but weather's rough, it's a bad day. You're thinking, okay, maybe it was turbulence, okay? So you're still doing 100 knots. you want to land at about 65. Okay, so you're going to slow down a bit, okay, to get to your landing speed. And then when you reach your runway, and it's windy and it's icy and it's really short, you think you're doing, say, your landing speed, which in a light aircraft, general aviation aircraft, might be 60 knots, 60 miles per hour, but you're actually probably, what is it, plus 20 or whatever in that situation. So you're coming in really hot. You're doing 80 knots, okay? So when you hit that runway, you might realise at the last minute and do something about it, but all things being equal, distraction in the back, you're tired, you really want to be on the ground, you're doing 80 knots, things are flashing by. It always looks like things are going quick when you're landing anyway, so you might not realise you're too fast. So you might land, okay, if you're lucky, but chances are you're going to die, okay? Because if you're going too fast, you haven't got enough runway. You might have crashed when you put the flaps out when you're going too fast. You might have crashed when you hit the runway because you were going too fast, or you're not going to stop before the end of the runway. Okay, so just because of some distractions and that blockage, you've had problems, okay, of that misread. So the lesson to take away from that is, with a blocked pitot tube and a static system that's working, okay, as you ascend, okay, your airspeed indicator is going to overread, and as you descend, it's going to underread, okay? Problem, you're going to come in too hot, you're going to come in too fast, okay? So that's the problem with a blocked pitot tube. So let's say your pitot tube this time is all good. Same scenario, we've still got, Mr. Caruso in the back seat. He's burping and farting and making your life a misery. Okay, and you're doing 100 knots, cruising at 100 knots, and suddenly your static port locks up. Okay, so now this pressure stays the same. Okay, so now that scenario reverses itself. Okay, so if you can remember how you came to that first scenario, okay, when you start to if you're slowly cruising up doing a nice slow climb to your cruising altitude, as you start to go up, this meter, instead of overreading, is going to underread. Okay, so, it's going to go down. So, you might notice that, and that might be a bit of you might go, what's going on there? So that could be a good thing. But say you're just cruising, okay, so it will underread, okay, so let's keep that in mind. But say you're just cruising and then you start your straight in approach, okay? Now, what's going to happen?
The pressure.
Are we going to overread or underread, first of all? You're going to overread, okay? Yeah. So this says 100 knots, okay, so now it might say 120. Okay, so this is a static blockage. So it's going to be the opposite. So instead of coming in hot, what's going to happen is you're going to be reading 100 knots as 120. And so you want your speed at landing to be 60 knots, okay? Keeping in mind that your stall speed might be 50 knots, okay? That might be your stall, because you come in pretty slow. You've got usually 15 or 20 knots to play with when you land, okay, in a light aircraft. So if this is reading, under-reading by a lot, what's going to happen is, overreading, let's get this straight. What's going to happen is you might actually be really close to your stall speed and not even realise it, okay? So instead of coming in hot, what's going to happen is you might be getting close to the runway, slowing down, putting out flap, doing everything you need to do, and you think that you're doing 60 knots, when in fact you're doing 40. And you'll get that little stall shutter, and you might be 400 or 500 feet above the runway, and the plane will just go, and you'll die. Okay? So that's the scenario for blocked pitot tube. Means you're going to come in too fast. Okay, you'll be going faster than you expect to be going. Blocked static tube when you land means that the speed is actually reading so that you think that you're going faster when in fact you're going slower. So you're getting closer to a stall. So block pitot means you come in too fast. Block static means you come in too slow. Okay? And they're both bad scenarios. Depending on how bad the blockage is, that's how bad the instruments will read. Yes?
What happens if that little water tube?
Yes.
The back valve,
Yeah,
if
good.
that gets blocked?
Good. If that gets blocked, you can get water in the system and it can cause icing inside, okay? But you might get away with it if it's not an icy day. It probably won't be a massive issue. It could cause some issues with that total pressure and the calibration, but it's not a massive issue. But if you get icing here, right, and this doesn't ice up, what do you think is going to happen?
You're going to lose all the pressure. Or you're going to lose all the air.
So what do you reckon your airspeed indicator will show? 0. Good. So you'll have the same pressure. It's almost like having a static port on both sides of the transducer. Okay? So you've got static air on both sides of the transducer. That ram pressure is what actually pushes the transducer. So if you've got static coming in here and static coming in here, and they're the same, there's no pressure. Okay? It's like being in a still room. Okay? So that transducer is not going to do anything. Your airspeed is going to be 0. That's great, kind of, because at least you know it's not working. But unless you're a very experienced pilot in a light aircraft and you know what the attitude, like what things should look like outside the window and how the angles of the aircraft should be, like views out the window and sort of stuff, that's really hard to do, to fly an aircraft without that airspeed indicator. Like that would be, you just don't want to think about it. But that can happen as well, okay? So that's another thing. And I think the same thing would happen if you blocked this, and this as well. I don't know. That's just giving me a headache. If they're both iced up at the same time, I think your airspeed would freeze at its current airspeed. So that would be an indicator as well.
With the, I can understand with the Pitot tube freezing up because
Yep.
you've got equal pressure either side.
Yep.
But with the hole out the back of the static,
Yep.
there's no, wouldn't the pressure inside break the ice? So it would only freeze up once the pressure was equal inside anyway?
What you're trying to say that, because you're flying along, right? There's a pressure being applied here, right?
Yeah.
Icing can happen really quickly.
Yeah.
So you can basically, if there's rain and sleet happening here and this is really, really cold, you can have a plug of ice form over that, like.
Yeah, that one I understand.
Yeah, yeah.
So even if the
Yeah.
pressure inside, you've got the outside
Yeah.
pressure.
What's the?
But in like the drainage hole, you've
Yeah.
got pressure inside, but the idea is not to have pressure outside.
The drainage hole is really tiny. I mean, it's even smaller than the calibrated leak in the back
Sorry,
of.
I meant the static hole.
Oh, it's static.
So you've got no pressure pushing in, but you do have a pressure pushing out. So when would the static freeze up, but not the...
This differential is not massive, so it's not enough to like stop something from forming over the.
Right, okay.
You know what I'm saying? Like it's not massive amounts of force, so it can ice up. This is more common, an icing situation, than this, but both of them have happened. Sometimes you get insects blocking these things as well, or debris. But I'm hoping that, at the very least, you understand that a pitot failure, and you can look up heaps of disasters that are involving this sort of thing, icing up of pitot tubes and static ports. It's really a nasty situation to have. Probably now in some aircraft you'll have some GPS information. So these days, most of your pilots probably have a GPS watch that would give them airspeed. So they could probably get themselves out of a pickle like this. But back in the day, it was a really severe situation. And it can still be a problem because you might just go, I'm trusting what I'm seeing. This makes sense, I'm not worried. Until, you're too slow or you're too fast, and in which case it's probably too late. So that's why obviously maintenance and all that sort of stuff is really, really important as well. Which coincidentally is the segue into the next thing we look at, which is the non-destructive testing and all that sort of stuff of aircraft, and the checks that you need to do to make sure the aircraft operates properly. So that's pitot static, and I'll hit stop now. And